Hey, math peeps. Welcome to our last lesson on rational expressions and equations. And this one focuses primarily on word problems. So in our last lesson, we talked about solving rational equations. Before that, our focus has always been on expressions and trying to add, subtract, multiply, and divide expressions. Then we got into equations where we had things on both sides of the equal sign, and we were actually able to try and figure out the value for our variable that actually made it work, okay, made the statement true. So then the last example I gave you on that lesson, I gave you a cute little word problem around two numbers and reciprocals, okay? Now we're going to kind of take that thought and go a little further with it in this lesson and really focus on some of the different word problems that you are going to see that are applications of rational equations. Okay, so I'm going to give you 3 or 4. We're going to have lots of fun. It's going to be awesome. Okay, here's the first one, and I'm just going to hide my face for a minute so that you can read the question if you don't have a book and you're working along with this video. 2 consecutive numbers are represented by x and x plus 1. If 6 is added to the first number and 2 is subtracted from the second number, the quotient of the new number is 9/2. Determine the numbers algebraically. Okay, so I know my original 2 numbers are x and x plus 1. I'm going to add 6 to the first number, so that'll be x plus 6. I'm going to subtract 2 from the second number, so that'll be x plus 1 minus 2. And then it says the quotient. The quotient refers to the answer to a division question. Okay, so that means I'm going to have x plus 6 divided by x plus 1 minus 2. And my answer is 9/2. So there's my equation. Okay, x plus 6 divided by x plus 1 minus 2. And my answer is 9/2. So now I can simplify this a little bit on the bottom. That's going to be x minus 1. And now really I'm right back to where I was in the last lesson. Okay, I want to try and get a common denominator. That's going to be 2 and x minus 1. The first fraction on the left here needs the 2, so I'll multiply by 2 on the top and the bottom. The second fraction needs the x minus 1. So x minus 1 on the top and on the bottom. I want to think about non-permissible values. X can't be 1. I'm going to get that common denominator like I just described. Okay. I can now pull the numerators out because my denominators say the same thing. So this is going to be 2x plus 12 equals 9x minus 9. And now I just solve for x. So I could subtract 2 from both sides. That's going to give me 7x on the right. I could add 9 to both sides. That's going to give me 21 on the left. I did it the other way. It doesn't really matter. I get negative 7x equals negative 21 instead of 21 equals 7x. Doesn't matter either way. You're going to divide and get x by itself, and you get x equals 3. Make sure that what you receive as your answer is not an NPV, and it's not. We're good. So x is 3. Now you got to make sure you answer the question. The question was determine the numbers. Okay, so my original numbers were x and x plus 1. So I've got 3 and 4. Okay, so the 2 numbers are 3 and 4. See, first application question down. Everybody's feeling good. Nobody's stressed out about word problems. Yeah? Okay. Next one. These are kind of a famous set of questions called distance, speed, time questions. And they're called distance, speed, time questions because the question deals with distances and speeds and time. Okay. We don't try to make things complicated. Okay. Aaron and Andrea set off at the same time on a 30-kilometer walk. Aaron walks 1 kilometer faster than Andrea. Aaron finishes the walk 1 hour ahead of Andrea. How fast was each girl walking? And how long did it take for each girl to finish the walk? So when you have a question with information like this, your thought process is going to be to set up some sort of a chart like I have shown you in your book and like I have on the PowerPoint slide right now. For those of you who are viewing at home and wanted to read that question, I'll just take myself off for a second. You can pause and get the question. Okay. Now, your job when you have a chart like this is to fill in 2 of the columns. Once you have 2 of the columns, you automatically have the third, and we'll talk about that in a sec. I know the distance for both Aaron and Andrea is 30 kilometers. So that one's done. I also know that Aaron walks 1 kilometer an hour faster than Andrea. So what I've done is I've called Andrea's speed X, and then Aaron is faster than that by 1 kilometer an hour. So I called Aaron's speed X plus 1. Okay. Now, here's the cool thing about distance, speed, time questions. Once you have 2 of those columns, you have the third because distance equals speed times time. Okay. So if I wanted to represent time, I could just divide both of these by speed, which means time is distance over speed. Okay. A lot of times you'll see these sorts of things written in a cute little triangle. And it just helps you try and figure out all the relationships. So if distance is speed times time, speed is distance over time, and time is distance over speed. Okay, if you like that, go ahead, I don't care. Just make sure you know that distance is speed times time. Okay, so for this guy then, that means my time can be written as 30 over x plus 1 and 30 over x. Okay, with that, writing that in there, I'm going to reread the question and I'm looking for one more piece of information that I haven't dealt with yet that's going to help me set up an equation. Okay, and the one other piece of information I've now highlighted in orange up top there. Let me just hide myself again for a sec. It says Aaron finishes the walk 1 hour ahead of Andrea. Okay, Aaron finishes the walk 1 hour ahead of Andrea. So Aaron's time is smaller, right? If she finished an hour ahead of Andrea, that means it took Andrea an hour longer. So where the equation comes from is the difference in time between Aaron and Andrea. If I take Andrea's time and subtract Aaron's time, I should equal 1. Okay, so that's what I've done. Andrea's time minus Aaron's time equals 1. Okay, so that's what I'm ready to now solve. I'm going to get a common denominator, but before I get a common denominator, I want to think about my NPVs. Okay, well, that's actually interesting because you're going to say, oh, okay, x can't be 0 and x can't be -1. But I'm going to see your 0 and -1 and raise you a, think about the context of the question here. We're talking about time. Time actually can't be negative. So the fact that you're saying x can't be -1 is kind of redundant. And we're talking about speed as our x values, right? Well, speed can't be negative either. It's okay because I already said time can't be negative. But we're going to have to be greater than 0. Okay, so x has to be greater than 0. Okay, so now I need a common denominator. So I'm going to need this guy to be multiplied by x plus 1 over x plus 1. This guy will be multiplied by x over x. And then the 1 has to get multiplied by x times x plus 1 over x times x plus 1. Okay, and that's what I've shown you here. Okay, so the 30 over x got multiplied by x plus 1 over x plus 1. The 30 over x plus 1 got multiplied by x over x. And then the 1 got multiplied by x times x plus 1 over x times x plus 1. Okay, now I'm going to distribute this first 30. So I've got 30x plus 30 minus 30x equals x squared plus x. And those are over x times x plus 1 right now. Okay, so that's looking like this. I then also pulled my numerators out because I had common denominators now, okay? So now 30x minus 30x is gone. So on the left side, I'm just gonna have that 30 equals x squared plus x. I got a cute little quadratic to solve now. That'll be fun. Let's bring the 30 over so that it's negative and I equal 0. Looking for two numbers that multiply together to give me negative 30 and add together to give me 1. That's going to be 6 and negative 5, which means x equals 5 and x equals negative 6. Okay, now think back to our conversation around the context of the question. X has to be greater than 0. So x needs to be greater than 0, so negative 6 is not an option. Okay, so really, I'm only looking at x equals 5. Now, what was x? Go back to that chart. What did you label x as? You labeled x as Andrea's speed. Okay, so Andrea's speed is 5. Now, you got to answer the question. The question said, what? How fast was each girl walking? Okay, well, that means Andrea was walking 5 kilometers an hour and Aaron was walking 6 kilometers an hour, 5 plus 1, right? And then how long did it take to walk? Well, Andrea's time was 30 over x, which is 30 over 5. So Andrea took 6 hours. And then Aaron took 30 over x plus 1. 5 plus 1 is 6. 30 over 6 is 5. So Aaron took 5 hours. So we have to actually answer the question. Andrea walked 5 kilometers an hour and completed the walk in 6 hours. Aaron walked 6 kilometers an hour and completed the walk in 5 hours. Okay. All right. See, that wasn't so bad. Let's do another distance, speed, time type question. And we're gonna go down the river. 2 kayakers paddled 18 kilometers downstream with the current in the same time it takes them to go 8 kilometers upstream against the current. The rate of the current is 3 kilometers an hour. Determine the speed of the kayakers in still water. Okay, so a couple of things we want to talk about. First of all, I didn't give you a chart. So we need to decide if we're going to set up a chart, what 2 things are we talking about, right? We know we're talking about distance and speed and time, but what 2 things over to the left are we talking about? Well, we're talking about what direction we're going on the river. We're either going downstream or we're going upstream, okay? So what I'm going to do is I'm going to let x equal the still water speed. That's what I've been asked to solve for, okay? And then I'm going to set up my chart with going downstream and going upstream, okay? And I'm going to start trying to fill in what I know here. Okay, so you need to understand what the current does. If I'm going downstream, I'm going my still water speed and the current is pushing me even quicker, okay? So my speed downstream will be x plus 3 because I get to go my still water speed plus the current speed. When I'm going upstream though, I'm going against the current. So if my still water speed is coming like this, the current is pushing me back like this. So I'll actually end up going slower than what I would have been able to do in still water. Okay, so that's going to be x minus 3 for the upstream. Okay, then I also know the distances for these guys, 18 kilometers for downstream and 8 kilometers upstream. Okay, so this is what I got going on right now. And then, like I already spoke with the other question, once I have 2 columns, I have the third. So my time is going to be 18 over x plus 3 and 8 over x minus 3. And then I'm looking for that one piece of information that I haven't dealt with yet that will allow me to set up the question. And for this guy, I'm just going to hide myself for a second so we can read this question again together. For this guy, it's right here, the same time, okay? So this guy equals this guy. There's the equation that I'm going to work on, okay? So 18 over x plus 3 equals 8 over x minus 3. Again, we want to have a conversation around NPVs. And again, for the context of the question, you can't just say x can't be negative 3 and x can't be positive 3. X can't be negative because we're talking about speeds, right? So actually, x has to be greater than 3. Okay, so now I need a common denominator. It's going to be x plus 3 and x minus 3. This guy needs the x minus 3 on the top and the bottom. This one needs the x plus 3 on the top and the bottom. So I'm going to go ahead and do that right here. Okay. So now that I have that done, I can just pull the numerators out. Okay. So while I do that, I'm going to distribute the 18 and I'm going to distribute the 8. So 18 times x will give me 18x. 18 times -3 gives me -54. 8 times x gives me 8x, and 8 times 3 gives me 24. Okay, so now I'm going to solve for x. I'm going to subtract 8x from both sides. That'll give me 10x on the left side. I'm going to add 54 to both sides. That's going to give me 78 on the right side. And now I just have to divide by 10. So x equals 7.8. Now, x, you always got to ask yourself, what was the question, right? So x is 7.8. X represented the still water speed, and that actually was the question. It said determine the speed in still water. So I just have to conclude and make sure I answer the question. So the still water speed was, or is, 7.8 kilometers an hour. Okay. All right, so that's where we're going to stop. And that's where you're going to get going on your practice. Okay, so I've listed your homework here. Just things to keep in mind. So we always get stressed when we see a bunch of words in math. And you're not alone when you see a bunch of words and you get stressed, okay? It's a very, very common reaction. For whatever reason, our brain doesn't like to associate math and a bunch of words together. Okay, so what I need you to see here is this is no different than what we did yesterday, except that you are building the equation. Okay, yesterday I gave you the equation and said solve. Now I'm giving you a paragraph where you have to get to the information out of the paragraph, come up with the equation, and then solve. Okay, but when you're faced with a paragraph, you need to ask yourself, okay, what have I been given? What information has been made available to me? And why would they make that information available? It's very, very odd for us to give you information you don't actually need. Okay, so think about that. Okay, think about, okay, why did they tell me this? There must be a reason they told me this. And how could I use this to get to an answer? Okay, take it piece by piece as you're trying to build these things. I am your ally. I'm here to help you. Okay, so make sure you connect with me if you do have any questions as you're going through this homework. Okay, this is going to end our rational unit together. The next unit I'm going to be doing is absolute value functions and reciprocal functions. Okay, so if you're following along in the order that I'm teaching the class, that's where we're headed next. If you're doing a different order, that's cool. I'll see you for whatever's next on your list. Okay, don't be a stranger though, guys. Make sure you're asking questions. Make sure you're doing your homework. I cannot emphasize how important that is. Okay, you guys got this. Okay, I'm with you. You guys can do this. Take care.